All right, so today we are talking about trigonometry, doing a quick review of sine, cosine, and tangent. So what we have here are the ratios of combining the sides with the angle given to find the appropriate proportion. You may have also seen it written out as SOHCAHTOA. Sine is the ratio of opposite sides to hypotenuse. Cosine compares adjacent to hypotenuse, and tangent will compare opposite and adjacent sides. Of course, the hypotenuse is always the longest side, and the adjacent and opposite sides are relative to the angle given, which is also called the reference angle. Let's look at an example. So we notice this triangle has two angles marked. It asks us for the sine, cosine, and tangent of all three of those angles. Of course, they don't give us any numbers, which means we are answering with variables only. So the ones that we use will vary depending on which angle we're using, right? So for theta, our opposite side is over here. Our adjacent side is closest to the marked angle. And the hypotenuse is the longest side of the triangle. So for sine, since that compares the opposite and adjacent sides, we're just going to get P over R. All right, cosine theta. Cosine compares adjacent and hypotenuse. So it's going to be our Q and our R. And tangent compares our opposite and adjacent sides. So it's going to be P and Q. For the other three, we notice that we are switching the angles. So if we use the angle over here, right, the hypotenuse is still in the same spot, but now P is closest to the marked angle, and Q is opposite the marked angle. So notice how that's going to change our values. So now, if we compare opposite and hypotenuse, we get Q over R. If we compare adjacent and hypotenuse, we get P over R. And if we compare opposite and adjacent, we get Q over P. All right, so that's how we find sine, cosine, and tangent for angles in a given triangle. For our next example, we're going to use our trig functions to solve for a missing value. It says find in two decimal places the unknown length. So the first thing we want to do is look at which angle they gave us. Again, that's our reference angle. So we have the 68 degrees given. So our hypotenuse is the longest side, right? Our opposite side is furthest from the marked angle, and our adjacent side is closest. So if I look at what I know and what I'm looking for, I'm missing the opposite side and I know the hypotenuse. So what I want is an equation that uses sine. So the sine of the given angle is equal to the opposite side over the hypotenuse. And now I just solve it like an equation, right? And if you're having an issue seeing what goes where, rewrite the sine over 1 so that we have a proportion. And then we're just going to use cross multiplication. So x times 1 gives me x. 19 times the sine of 68 degrees is something that I need to approximate in my calculator. I want to make sure that since I'm dealing with degrees, the calculator is set to degree mode. Right? So make sure that you go to mode and highlight degrees. All right, so if I do that, type it in just as I see it, I should get 17.62. Alright, so for this one, we notice they gave us two sides, and we are missing the angle. So we're going to set this up just like we did the last one, only there's going to be a small, subtle difference. We're still looking at the opposite side, hypotenuse, and adjacent side. So we still are going to have to pick a trig ratio just like we did last time. This time I know my opposite and adjacent values, which tells me I want to use tangent. I'm missing the angle, so I leave it as a variable. And then I put up my fraction. Since I do not know the value of the angle, I cannot type my tangent in and get a value. Right? So I'm not going to be able to solve this using regular trig functions. However, we know that we have our inverses. Right? An inverse is where I switch the value I'm plugging in with the value I'm getting out. So if I don't know the value of my angle, I can rewrite this as theta equals the inverse tangent of 5/4. Right, so I notice on my calculator, the inverse buttons are the same as the regular trig buttons, only I have to press second before I type it in, right? So second tangent 5 divided by 4. So my missing angle is 51.3 degrees. If you're doing this at home and you do not have a graphing calculator, most scientific calculators can do your trig functions. Even cell phone calculators can do it. So if you take your cell phone and you flip it, rotate it long ways like you're taking a picture, your your calculator app should flip to turn it into a scientific calculator, which should have the sine, cosine, and tangent buttons. There's some examples for you to try on your own. All right, so the next thing we need to review is the law of cosines. In IB books, they'll call it the cosine rule. This is the same thing, right? So I might use these interchangeably when I'm talking. Notice there's 3 different versions of the formula, but they're all saying the same thing. They're telling us that the angle across from a given side fits the pattern. So the side length squared is equal to the other 2 side lengths squared minus twice the product of the 2 side lengths and the cosine of the angle. So for me, it was always easiest to remember this version of the formula because it looks like Pythagorean theorem with some extra junk stuck on the end. So how are we going to use this? We look at the triangle. We have a missing side. we want to find that missing side. I was given an angle. If the angle is across from the side, then I plug it in like I'm plugging in a hypotenuse in Pythagorean theorem. So x squared equals 21 squared plus 15 squared minus 2 times 21 times 15 times the cosine of 105 degrees. Notice I don't actually have to solve anything, right? My x squared is by itself already, so all I need to do is take my calculator, type in the right side of that equation as I see it, that'll give me a value. So I get 829.06. Notice I'm not done. Still have that squared there. I do not want that. So I'm going to have to square root both sides. So if I take the root of 829, I get about 28.8. And the last thing for today, the law of sines. Again, they will often call it the sine rule as well. We can use those interchangeably. Law of sines is easier to remember because it's basically just telling us we can use a proportion with the sine of an angle and its opposite side. So if I'm looking for x, I should make my proportion x over the sine of 48 degrees is equal to 23 over the sine of 37 degrees, and then we cross multiply. All right, so x times the sine of 37 equals 23 times the sine of 48. If I'm solving for x, we just want to divide the sine of 37 over. And then we can type that in our calculator. Remember that our fraction button can be found by hitting alpha and then y equals, and then picking this guy right here. So if I type 23 sine 48 divided by the sine of 37, and I hit enter, x should be about 28.4. All right, that's all we have for today. I'll see you next time.